Scotland produces around 13 million tonnes of waste every year. It is vital for this waste to be segregated efficiently for recycling, which has a massive effect in the fight against climate change. Recycling helps to prevent deforestation by reducing the need for new materials, and also minimises the volume of greenhouse gases from landfill sites. Currently, waste is often sorted using manual picking lines, which is tiring and monotonous work for staff. An improved method of sorting using robotics would minimise safety concerns and allow 24/7 operation. That's where we come in.
We are 4 master's students from the University of Strathclyde, and we have designed IRIS, an intelligent recycling integrated system to replace the tedious and hazardous work of the manual picking line. IRIS will use a combination of machine vision and deep learning techniques to classify the materials of plastic bottles, glass bottles and aluminium cans. They will be separated into bins, labelled either glass, plastic or metal. If an object does not fall into one of these categories with a great enough certainty, it will be placed into a bin labelled Other. The objects will be brought onto the camera's field of view using a conveyor belt.
An object detection algorithm was created to track objects as they come into the webcam's view and determine when to stop. It was also able to recognise the object's orientation.
The gripper was designed to pick up the object from the detected orientation and place it into the correct bin. All parts of the design were created and assembled using SolidWorks.
The design consisted of a gear system connected to a servo motor, which was controlled using a force-sensitive resistor and an Arduino. This control system detected when the gripper was in contact with the object, and locked the arms in this position to transport the object and release it above the correct bin.
An image classification network for recyclables was used to determine the material of the object and hence which bin it should be placed in. This was created using the Robot Arms camera as well as the MATLAB deep learning toolbox in order to complete transfer learning of a Google Net network. We used our own dataset for training, with images of plastic bottles, glass bottles and aluminium cans, all of which can commonly be found in the UK.
ITRA, the interfacing toolbox for robotic arms developed at Strathclyde, was used to control a KUKA robotic arm in MATLAB. A movement algorithm for picking and dropping objects was then developed, and this was successfully integrated with control of the gripper.
IRIS presents a novel method for the automated separation of recyclables. By eliminating the need for a manual picking line, IRIS is expected to improve working conditions and reduce the number of accidents at waste management facilities. IRIS can sort between 900 and 1200 items every hour with a minimum accuracy of 79.6%. With IRIS, we are one step closer to winning the fight against climate change.